this video, I went through my back catalog and found the best videos on writing the equation of an ellipse when given certain pieces of information, like the center, the foci, the vertices, the major vertices, the co-vertices, the major axis, the minor axis, as well as eccentricity. All of these examples are provided inside of this video, and if you go through this video step by step following my process, you are going to have a better understanding of how to write the equation of an ellipse. I hope you enjoy. So, ladies and gentlemen, hey, there's no gentleman here today. Look at that. You know what I told you guys about my first job? I'll say it. My first interview. Yeah, it's on video. My first interview, though, was in a school in Jacksonville. And before I even accepted on the Mandarin, they asked me, the only position they had open was for a math teacher, but it was for like the early pregnancy. So it was like for all the girls in the city, like that would, that were having a baby, that I would be like their math teacher. So, just fresh out of college, and they say, oh, do you think that would be a good fit? I'm just like, sure. Classroom full of ladies, the women that are all ready to have a baby, that sounds like a good idea. Unfortunately, they didn't give me a call back, so I wound up here. But
are you filming
anyways,
this right now?
yeah, I thought it'd be a fun intro, I guess. So anyways, so we're given the vertices, -6, or plus or minus 6, comma 0, and the foci is plus or minus 2, comma 0, and I'm asking you to write the equation. So, ladies and gentlemen, remember the parabolas when I said I was giving the information? The first thing I said is just, there's only two equations. It's either opens up or down or left and right? The only way to figure that out is to plot the information and see what's going to make sense. Exact same thing with this. So let's just plot the information and see what makes sense. So our vertices are plus or minus 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Foci, plus 2, negative 2. So we have foci, vertice, vertice. Now remember, ladies and gentlemen, there's only two ellipses that we're dealing with. One that's vertical, and one that's horizontal. Now, just out of, I don't know, a random guess, if you were to say these are the points of one of these ellipses, would you recognize that it to be a ellipse where your major axis is vertical, or where your major axis is horizontal? Horizontal, right? It's pretty obvious. You can notice that, that the vertices, the foci, all have to be on the major axis, and since this major axis is going horizontally, then you have a horizontal ellipse, right? So let's just eliminate this right here. All right, now, remember, when we're looking at this, if I give you the vertices and the foci, remember the vertices and the foci are plus or minus the same distance from your center, right? If I say your vertice is 6 units to the right, then it was also 6 units to the left, correct? So therefore, what is going to be our center? Because we need to figure out what this center is.
It's always 0, 0.
In this case, the center is 0, 0, yes.
No,
Oh, the problem actually said,
it starts with
oh, that's nice. You're right, they do say the center's of the order, so that's good. Good. Right, you're right, because all the way up to 35, then they change it to 9. Okay. So we have the center is 0, 0. So that helps us because now when we write our equation, we know our formal was x minus h. For a horizontal, then it would be a squared plus y minus k squared over b squared equals 1. However, do we have an h and a k? Yeah, there's 0, right? So now we can just say x squared over a squared plus y squared over b squared equals 1. Okay, so now let's just go and see if we can figure out what our a and b are. Remember, a is going to be this distance, right? Doesn't matter if it's going to be your positive or your negative. What is this distance? What is this distance squared? Well, the distance was 6, plus or minus 6. You square a negative 6, you square a positive 6, it doesn't matter. You're going to get
36.
Good. So now we have y squared over, b squared. Now our problem is we don't know what b squared is, right? But the other information they gave us was they gave us c. And remember we talked about a, b, and c are related to each other. where we can say a squared equals b squared plus c squared. So if I know a squared is 36 equals b squared plus c squared, so c is 2, so c squared is going to be 4, minus 4, I get 32 equals b squared, square root, b equals plus or minus, take the, simplify this into 4 radical 2, yes, but we don't need to do that, right? Because all they're asking us is what is b squared. So, we can just leave it like that. B squared equals 32. Okay? Because remember, you're looking for b squared, so we don't need to solve for b. We just need to know what b squared is. So, there's your answer.
So, in the like standard form of like that graph, where's B? Again?
Where's b?
Yes. Is it? No, in the graph. Like the relationships.
Oh. B is your distance. These are like, if you call this like a major vertice, call this like a minor vertice. It's where it's like the minor vertices on the minor axis. All right, any last questions? 33. So, by plotting the information, I go over -8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 4, 0, 1, 2, 3, 4. Those are my two vertices. Now, yes, the two vertices are on the outside end of your ellipse. And yes, the vertex is in the exact middle, right? Because remember, the distance from the vertex to a vertice is a, and a major axis is 2a, right? So it's just double that. So yeah, we can just look at this and say, you could count how large it is, which would be, 12, and then divide that by 2 to find the distance of a, which is 6. Or you could just count and find the middle. But anyways, I get it to be I get my vertex to be at -2, 0. Would everybody agree with me on that? So that's at -2, 0. All right, cool. So now we get into the most important piece of information that I told you from the beginning. We now have the two vertices and the vertex that lie on an axis. So we know that that axis must be the major axis, right? And what else lies on the major axis, Garrett? You have the vertices, the vertex, and the vertex, vertices, and the foci, right? Foci, whatever you want to call them. So, yes, that's exactly right. And we can show that by obviously looking at the foci, which is at -3 and -1, 0. All right? So now we see that this major axis is horizontal. Do you guys see? All that important points lies on the horizontal axis. So then it makes sense, Aaron, if you have to decide, should it be a horizontal axis ellipse or a vertical major axis ellipse? And you can see, all right, well, if Mr. McLogan's asked me to graph what the equation would be, then it's going to be very easy for me to see I need to use this equation. So I'll write out the equation, x minus h. Well, let's not write out the equation because I already have it written down. Let's write down the information we know. We know that the vertex is at -2, 0. So that's going to be x plus 2 squared plus y squared equals 1. We don't know. It's because it's y minus 0, right, which I can just write as y. Is everybody OK with that? Sometimes that confuses. So now, Sean, if we know, can we find the value of a, Sean? Because we need to now we need to figure out what a and b are, right? Yes? We need to figure out what a and b are. A, remember, is the distance from the vertex to the vertice. So do we know one of those distances? Yes. And what it is? Well, what is a? What is the distance from a vertex to a vertice? Here's the vertex, and we want to go vertex to the vertice. Oh, 6, right? Now, here's the question, though. Is it -6 or is it +6? But think about it. It doesn't really matter in this case. P was always the case of, we always go from P was the distance from the vertex to the focus. But P would also go in the opposite direction. But yeah, in this case, guys, we're squaring it, right? So it doesn't matter. The value of A the absolute distance from the vertex to the vertices, absolute distance is 6. So when I square that, I get 36. And I know that that distance has to go under the x because that's what Caroline was talking about as far as when or Zoe was talking about, or Michelle was talking about, that when you have the larger number under the x, that tells you it's elongating it horizontally. All right? So now we need to figure out b, and we have an issue with b. All right? JD, do you know the value of c? 1. And JD could find that value c by going from the vertex to the foci. That little distance, right? Distance from the vertex to the foci was c. So, right? Which is equal to 1. Now, c is not in the equation, so that's an issue. Correct? Yes? C is not in the equation. But Eileen, do you remember there's an equation that I provided that could help us with this? Do you remember what that equation was? It's written on the board. Yeah, it's right there. C squared equals a squared minus b squared. Yeah, it's that one. Yeah. So if I have c and I have a, is it possible for me to text my friend and find the value of b? Yeah, OK, it is possible. So I can say c squared equals a squared minus b squared, where c squared is 1 squared equals a squared, which is 36 minus b squared. All right, and then I'll just add the b squared to the other side. And so b squared equals 35. I'm not going to do the work because I'm kind of running out of whiteboard space. But yeah, you just subtract 1 on the other side too, right? So b squared equals 35. So there you go. That's it. That's the equation. All right? Oh, and then obviously, if we wanted to find, so b squared, square root of b, if you wanted to find b, you could take the square root of 35. That would be how far you'd go up there if you're going to graph it. All right? But we're not going to take the square root of 35 and do that yet. Not right now, not for what I've been going over. Welcome, ladies and gentlemen. So what I like to do is show you how to determine how to write the equation given the foci and the covertex of an ellipse. So the first thing we want to do is identify, do we have a major axis that's horizontal or vertical? So to do that, we need to at least write in the information that we have. OK, so the foci, which is at 4, 4, and 4, 14. So 1, 2, 3, 4, 1, 2, 3, 4. And then at 4, 14. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. OK, so remember, these are the foci. And then the one covertex is at 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. OK, now, what's nice about the information that we have is notice that the major axis, what lies on the major axis is the vertices, the foci, and the center. So therefore, I know that this has to be my major axis. Therefore, my major axis is vertical. Since I know my major axis is vertical, I'm going to write the equation x minus h squared plus y minus k squared equals 1. Since it's vertical, I'm going to have b squared under the x and a squared under the y. I'll get to the a and the b in just a second. The next thing here is one covertice. Now notice that, again, when we're looking into trying to determine the center, right? And the center of an equation is in the form of hk. Well, what's nice about the center is the half distance between your two foci, as well as the half distance between your two covertices, and the half distance between your two vertices, which we don't have anything for yet. So if I wanted to find just the half distance of my two foci, I can reason that my center, I'd probably say the half distance is going to be somewhere right around here. Now, since the covertex is 1, 2, 3, 4 units away from the center, or at least the major axis, it has to be 4 units to the other side. 1, 2, 3, 4 on the other side. All right. The next thing to also understand is that this is what we call the minor axis. And the minor axis and the major axis have to be perpendicular to each other. Now, let's get into some fun stuff. The distance from the center to our covertex is what which we give the value of b. The distance from the center to the foci, or one of the focuses, is going to be c. So we don't have C in the equation, but we're going to need to know C to help us figure out what A is. The center we did determine is going to be at 4, 9. So I'll say center is at 4, 9. That's the x and the y coordinate for my center. The value of B, the distance from the center to one of my co-vertexes, is going to be 4. So, I'm sorry, let's write out R. So I can say B is equal to 4, and A is going to be equal to the distance from my center to my vertice, which I don't have. However, there is a relationship of A, B, and C. So we have C squared is equal to A squared A squared minus B squared. So C squared, which we know is the distance from the center to the foci, which is 1, 2, 3, 4, 5. So I have 5 squared is equal to A squared, which we're trying to figure out, minus B squared, which would be 4 squared. All right, remember C is the distance from the center to foci, so that becomes 25 is equal to A squared minus 16. Now I'll add 16, and I get 41 is equal to A squared. So therefore, ladies and gentlemen, A would be the square root of 41. So we know B squared is equal to 16, and A squared is equal to 41. So now we know what A squared is, B squared is, and our H and our K, which is our center, we can now write the equation, which would be x minus 4 divided by 16 plus y minus 9. Oh, I'm sorry, these are all squared. Divided by 41 equals 1. So there you go, ladies and gentlemen. That is how you write the equation of ellipse given your foci and a covertex. Thanks. Welcome, ladies and gentlemen. What I'd like to do is show you how to write the equation of an ellipse given the major axis is horizontal with the length of 8, as well as the minor axis is vertical with the length of 4. So when we're writing an equation of ellipse, there's two different equations, one where the major axis is horizontal and one where the major axis is vertical. And thankfully in this problem they say that it is a horizontal. So therefore we know that A squared, which A represents the distance from the center to the vertices, is going to be under the x since it's horizontal. So therefore, the standard equation that we're going to write our equation in is x minus h squared all over a squared plus y minus k squared all over b squared equals 1. Now, remember the center is represented by h and k. So likely, we already have that information, right? So that's good. So remember, it's x opposite of h, though. So here h is -2, so opposite of -2 would be +2. So I write x plus 2 squared plus y opposite of 3 would be -3 squared equals 1. Now, the only problem is we don't know what a squared and we do not know what b squared is. But let's go ahead and graph a ellipse here. And let's pretend here's the center, here's vertice, and here's vertice. Remember, I said the distance from the center to a vertex, or one of the vertices, is a. Well, that distance has to be the same. So therefore, the distance from one vertice to the other vertice, or one vertex to the other vertex, is going to be, or is going to be 2a. So the length of the major axis is equal to 2a. So therefore, I can say 2a is equal to 8 divided by 2 divided by 2. A equals 4. Well, 4 squared is going to be 16. And then b, that's going to be the length of the minor axis, which again, b. So I can say 2b is equal to 4 divided by 2 divided by 2. b equals 2. And again, 2 squared will equal 4. So there you go, ladies and gentlemen. That is how you write the equation of the ellipse when given the length of the major and minor axis as well as the center. Thanks. What we have here, ladies and gentlemen, is we're given the foci of 0, 0 and 0, 8, and we're also given a major axis length of 16. And what they're asking us to do is to find the standard form of the ellipse. All right? So whenever you're given just points and they're asking you to find the standard form, yes? I believe this is number 41. Someone gave it in the book. So what we're going to do for this problem is, the first thing is, ladies and gentlemen, is just plot the points. Write a nice little makeshift graph that you can, and plot the points, because the main important thing we want to do is, do we have an ellipse that's going to have a major axis symmetry that's going to be horizontal, or we're going to have a major axis symmetry that's going to be vertical? Because if we can determine between those two, that will tell us which formula we're going to want to use. So what I have is I plot one foci at 0, 0, and the other one at 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's up, not 8. Over 8, that's 1, 2, 3, 4, 5, 6, 7, 8. Right. So, we have two foci, right? Now, knowing that your understanding of ellipses, remember our foci have to lie on our major axis, right? So therefore, here is our major axis. So therefore, is our major axis going to be vertical or horizontal? Vertical, right? Now, it says the major axis length is 16. Do you guys remember, so now we have an ellipse that looks something like this. We know that the distance to our foci is C, and the distance to our vertice is A, right? But the whole distance of the major axis is how far? How long? Well, here to here is A. It's 2A, right? So if I want to figure out what A is, I can just say 16 equals 2A divided by 2. A equals 8. All right? But here's where it gets a little point. Where is our center? Now the important thing is, remember that the distance, the absolute distance of C is where your foci is a distance away from your center. So therefore the center is directly in between your two foci. So I'm given my two foci. I know that my center is exactly in the middle, right? It's not near one foci than the other one, it's exactly in the middle. So I look at this distance and I say 1, 2, 3, 4, 5, 6, 7, 8. So I can say that 8 equals 2C. Therefore, C equals 4. So therefore, if I know that C equals 4, all I need to do is travel 4 units from my foci to find the center. 1, 2, 3, 4. So we can now say that the center is at 0, 4. And if the center is at 0, 4, and my A is at 8, that means I need to travel 8 units from my center to find each vertice. So therefore my vertices are at 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Does that kind of make sense what I have done so far? Okay. Now they're just asking us to find the standard form, so we don't really need to find all those vertices, but it was just a kind of good idea for you guys to understand where each vertice is in comparison to finding the foci and finding the center. But the main important thing we needed to figure out was what the center was, because to write the standard form, you have to know the center, and we have to know the distance of A and C, because in the standard form, so now we have a vertical ellipse, so we know that the formula we're going to use is x minus h squared plus y minus k squared divided by b squared divided by a squared equals 1, right? So what we're going to do is we're now going to plug in that information. The one last piece of information we need to figure out, though, is we don't know what b is, do we? But we now know what a and c are, and we talked about the relationship between a and c. It's going to be a squared equals b squared plus c squared, right? So therefore we could say 8 squared equals b squared plus 4 squared. So therefore we have 64 equals b squared plus 16 minus 16, and therefore we're going to have 48 equals b squared, take the root, and that will be 4 square root of 3. I'm sorry, what am I doing? You don't need to. I'm in such a habit of rationalizing or simplifying my radicals. We don't care what b is. We just want to know what b squared is. We're not trying to find how wide our ellipse is. So we just have, so now we know what b squared is. So to plug everything in, h is going to be 0, so we're just left with x squared plus y minus 4 squared, all over b squared is 48, all over a squared, which is 64, equals 1. So there you go. That's your standard form. Okay? Does that make sense? Yes?
I was confused. It says we have a major axis of 16. So that means that, like, the length obviously is 16, right? So why would, like, the vertices is more than 16, is what I'm saying. Like, you know what I'm saying? Like, from vertice to vertice, it's more than 16.
16. It should be 16.
Is it?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
Okay,
11,
yeah.
12, 13, 14, 15, 16. So yeah, all I did was, that's
Okay.
exactly what I did. I found the
was
center,
thinking it
I
was
took
like
16, I divided it by 2, and then from the center, I added and subtracted
And
A.
then you just added how far the center, you just added C to the foci. You know what I mean?
Yeah,
Find the
it's,
vertices.
well, what I did is here, I'm given the 2 foci, so what I did is I divided it by 2 to find the center. And then once I found the center, then I could move back up.
Okay.
Because same thing, the center evenly divides the distance of the foci and the vertices. So it's right, the center is right in between all those points, which all lie on the major axis. Alright,
It gets me out of
so, when doing a problem like this, ladies and gentlemen, where they do not give you a formula, the best thing I want you guys to do, just like when we had the parabolas and they gave us information, the best thing I would ask you guys to do is just take a little separate sheet and just plot what information we have. So it's just giving us points, right? We need to obviously understand what those points are. Well, let's just go and plot them. So we say vertices are at 0, 2, and at 4, 2. Then we have the endpoints of the minor axis are at 2, 3, and at 2, 1. Okay, so remember, ladies and gentlemen, there's 2 types of ellipses we have. We have a horizontal ellipse and our vertical ellipse. Remember that the larger length is what we call our major axis. So we're given, and that's at the end of our major axis is what we call our vertices. So here are our 2 vertices, right? That's our endpoint. The vertices are at 0, 2, and 4, 2. So if I had a parabola that's horizontal, your vertices would look like this. And if it was vertical, the vertices would look like this. So just by giving you that information and plotting those points, what type of ellipse do you think we have? A one with a major axis symmetry that's horizontal, or a major axis that's horizontal or vertical? Horizontal, right? So automatically, now that we know that it's horizontal, let's go and write out the formula for it. Because they're asking us to find the standard form of the equation. So we have x minus h squared, since it's horizontal, a squared, go below it, plus x minus k, or sorry, y minus k.
So if it's horizontal, you use that equation?
Yes, if your major axis is horizontal. Okay, so we have that.
Wait, what about the major axis?
The major axis, which is your a, this right here.
Okay.
If it's horizontal, then that's what you use. If it was vertical, then your a and b would be swapped.
Oh.
All right, so do we know what a is, or at least what a squared is? Well, remember a, ladies and gentlemen, is this distance. Since we're not dealing with the vertical, we can erase this. Remember, this distance from the center to the vertices is what we call a. And notice, this is also a. So what is this distance, which is this total distance here? Because that total distance is going to be what? 2a. So let's count. We can just simply count what is the distance between our 2 vertices. 1, 2, 3, 4. So we could say 2a is equal to 4. So therefore, a equals 2. Right? And therefore, we could say a squared equals 4. And then what's important about that is if I know that A is 2, that means if I go to the vertice, if I travel 2 units, where do I go to? The center, which is going to be right around there. All right, not yet. But let's actually
I
graph.
said the vertices was the ones beyond them.
Let's graph this a little bit larger.
No, it's
Okay.
yeah, it's like.
So now we're given also the distance of B. So remember from this point, from your minor axis, from here to here is B, and from here to here is B. So therefore the total distance of the minor axis is what? 2B. So let's count how long is this distance? 1, 2. So we could say 2B is equal to 2. Therefore, B equals 1, and we could say B squared equals 1. Yes? No? Maybe? So? Flash. So I guess you could say B squared is equal to 1. All right?
Can you do B again? I didn't see.
So we figured out A was distance from here to here, right?
Yeah.
B is the distance from here to here, the minor axis. So B is on your minor axis. If A is from here to here, B is from here to here. So B is the minor axis, the smaller axis. Okay? So since from here to here is 1, and from here to here is 1, so therefore we could say 2B, which is double the distance, is equal to 2, so therefore B equals 1. So now we have a point for our center. So now we can say, we know B squared is 1, A squared is 4, and we can say now our center is 1, 2, 2. At 2, 2. So we know center is 2, 2, B squared equals 1, A squared equals 4. And do we need to figure out what C is, where the foci are? They're just asking us to find the standard equation. Do we care? Do we need to know what C is right now? No. If they asked us what's the foci, then yeah, we had to figure out what C is. But we don't need to figure C. We already have all the information we need to create a formula. Now, I'll just ask this question one more time because I always like to hear the answer and make sure everybody understands it. Why don't I need to figure out what X and Y are? I figured out what H, K, A, and B are. Why do I not need to figure out what X and Y are?
Is there 0? It's just, I don't know.
Not 0
Don't
yet.
have a coefficient fixed.
The variables on that.
Yes, they are variables. What do X and Y represent?
X and Y. Oh, intersects. I don't know.
Yeah, X and Y, ladies and gentlemen, represent all the points on the ellipse, right? How many points are there on the ellipse? Infinite many, right? How many centers are there?
One.
How many vertices are there? 2, right? So those are finite points. But X and Y is infinite, right? So that's why we're not solving for an X and Y point. Those are just given into your formula. So therefore, let's just plug it in. So we have our center, so it's going to be X minus 2 squared over A squared, which is 4, plus X minus 2 squared over 1, which we don't really need to write, but I guess I will, equals 1.
Like, you see,
Okay?
guys, it's the middle of that.
And that's it.
Welcome. So what I like to do is show you how to determine the endpoints, write the equation of an ellipse when given the endpoints of the major axis and the endpoints of the minor axis. Now remember, the endpoints of the major axis are going to be our vertices, and the endpoints of our minor axis are going to be our co-vertices. Now, the reason why that's important is because remember, the major axis, if it's horizontal, is going to produce one type of equation, and if it's vertical, is going to type a different type of equation. And that's really, the different types is really where the values of A and B are going to be, where A represents the distance from the center to a vertice, and B represents the distance from a center to one of the co-vertices. So what we want to do is first plot this information to be able to help us kind of determine, first, where is the center, and 2, what are the values of A and B. So I'm going to, my major endpoints are at 2, 2, and 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 2. So I'm going to label those as vertices, vertices. And then my major axis endpoints are at 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. And at 5, 1. Covertice, covertice. So you can see in this case that my major axis, the axis, the line between my vertices is horizontal, and my axis between my covertices is vertical. So therefore, the formula that I'm going to use is x minus h squared plus y minus k squared equals 1, where since it's horizontal, my a squared is under my x, and my b squared is going to be under my y. So now what I need to do to be able to determine what my value of a and b are, I first need to identify where the center is. And the center is going to be where my vertices and my covertices, the axes, the minor and the major axis, intersect. It's also half the distance between the two vertices and half the distance between two covertices, which is at 1, 2, 3, 4, 5, 1, 2. So you can say that the center is at 5, 2. So here is my center. Now remember, the distance from the center to the vertice is a, and the distance from the center to the covertice is b. So all I simply need to do is say, all right, so from center to a vertice is 1, 2, 3, and from center to the covertice is 1. So now I'm going to enter the information. So I say a equals 3, and b equals 1. Now, to solve for my equation, I have x minus h, which is my x opposite of h, which is my h is 5, squared plus y opposite of k, which is 2, squared equals 1, divided by a squared, which is 3 squared, which is 9, divided by b squared, which is 1, 1. So there you go, ladies and gentlemen. That is how you write the equation of the ellipse when given the endpoints of your major and minor axis. Thanks.
As long as you guys know what the formula for eccentricity is, which E equals C over A, which is not the hardest thing for you guys to memorize, right? You guys have memorized a lot of like crazy stuff. Eccentricity, C over A. Pretty sure you can say it to yourself 5 times, and you'll have it memorized. So that's nice because I now know 2 is C, and 3 is A. Well, guys, to write an equation, all we need is the center, which they already gave us. And we need to know A, B, and the center. And then also we need to know where our major axis is, which they tell us. It's a horizontal major axis, right? So this is like, literally, they're just giving us all the information. So we know that our formula is going to be x minus h squared all over a squared, because this one has a horizontal major axis. So that's our equation. The only thing we need to make sure we know is what is our A, or I'm sorry, our B. So again, we go to our formula. C squared equals A squared minus B squared. C squared is 4 equals A squared, which is 9, minus B squared. So 5 equals B squared. Well, guys, I have my h and my k. I have my b squared. My a is 3. So if a is equal to 3, that means a squared is equal to 9. So look it. I got everything I need.